Well, we're going to begin working and doing some modeling with nonlinear regression. And we're going to look at, in this case, we're going to look at exponential regression. We're going to look at logarithmic regression, logistic regression. There's power regression, quadratic, cubic, and there's many different types of regression analysis that we can do. Again, primarily we're using our great tool of our calculator to help us both graph a scatter plot, find an appropriate line of fit, and then we can use this data and our regression analysis to help us to predict what may happen out in the, well, I would say future, later years, based upon that regression analysis. So let's see what we have here, because we're going to first go look at an exponential regression. And so we've got, says that the internet experienced rapid growth in the 1990s. The table shows the data of users in millions for each year during the decade. Use exponential regression to model the data, and then use your model to predict the number of users in 2008. Let X be the number of years after 1990. All right, so 2000, we're going to make a prediction in 2008 based on this data that was obtained through the decade of the 1990s. All right, well, we're going to hop over to the calculator, and we're going to graph this data in a scatter plot, and then we will use an exponential regression model, and then we'll make a prediction what the number of users were in 2008, which is 18 years after 1990, right? Let's see, 1990 minus 2008, that'd be 18 years. All right, well, let's go to the calculator. All right, so we're going to graph this data in a scatter plot, this data concerning internet usage in the decade of the 1990s, and then after we get this graphed and our regression analysis performed, we're going to make a prediction as to what the how many people are using the internet or internet usage in the year 2008. I know this is a little bit dated, but hey, the textbook's a little bit old, so we're just going to go with what we got because the principles are all the same. So the first thing I want to do, I'm going to make sure my stat plot's on. I'm going to hit second y equals. That takes me to the stat plot. Oh, and I see that it is off. So I'm going to hit enter. Plot 1's off. I'm going to hit enter again to turn it on. I'm looking at the type here, and the type is a scatter plot. I see all those little dots on the X and Y axis. X list is L1, Y list is L2. That all looks good. And I could just, now we're going to quit this. Now, to enter the data, I'm going to go to stat. Stat button right here. I'm going to say edit. Now, I have already entered the data from this table that we just saw previously, and that is also in your book on page 201. And if you notice in my L1, which is my X values, I didn't put 1991, I just put 1. And then I 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are years after 1990. And then in L2, I entered the data that was given to me about internet users. So the data has already been entered. And now I'm going to get my regression equation by hitting stat again. And now I'm going to calc. And I'm going to choose, I'm going to scroll a little bit. You can see I've got several different types of regression analysis that I can use. And right there at 0 on this calculator, I see EXPREG, exponential regression. And that's what I've been told to do. Oh, well, let's see. Well, I'll go ahead and do that. I could have looked at my scatter plot first and probably should have, but we'll look at it here just as soon as I get through. All right, so I've got this exponential regression. It's getting ready to come up. I'm just going to enter all the way through here. And it gives me an exponential equation. If you look up at the very top, it's got y equals a times b raised to the power of x. And so a in this case, if I were to round it, let's say to the nearest hundredth, Well, let's do the thousandth. How about that? It would be 0.443 times B, 1.696 raised to the power of x. And if I look at my correlation here, I see it's 0.99. So this exponential regression is going to fit my scatter plot pretty well. Let's go look at the graph first. I should have done that maybe before. I mean, it doesn't matter, but as far as the end result. But let's see what our graph looks like. Now, to see it, I probably want to go to Zoom and choose Zoom Stat, which in this case is option 9. So it'll fit my window. And I got something in y equals I see there. Let me erase that. All right, let's go back to Zoom Stat. All right, and you can see that this has this scatter plot has the characteristics of this exponential function. It starts off hovering down around the near the x-axis, as y values are not particularly large at this point, and then all of a sudden it just takes off. Now, let's see. Let's get this where we can get and actually graph our regression equation. So I'm going to go into y equal, and then I'm going to hit vars, variables, and I'm going to choose option 5, statistics, vars, option 5, statistics. And it brings me to this menu, but I'm going to go over here to the EQ, equation, and option 1 is a regression equation, so I'm going to choose it. Now you can see that it put that regression equation in my y equals, and so it's all there. I can see part of it here on the screen. Let's go back into the graph and let's see what happens. And there we go. It graphs that regression equation, and you can see it really fits pretty well the scatter plot of the data that we entered. Now, I've got to make a prediction. It's because it wants me to predict what is going to be the number of internet users in 2008. Well, that's 18 years after 1990. And I need to go check my Windows settings because I'm going to ask my calculator to find that value for me when X is 18. But my Windows settings got to be large enough that it'll recognize that X value. So I'm going into Window, and you can see that my X max here is at 10.9. So I'm going to scroll down here, and I'm going to change it to 19 because I want to see what happens when X is 18. What happens in the year 2008? What's our prediction based on the data that we have from the 1990s? All right, so I've changed that, and now I'm going to go into second calc or second trace, which is the calc feature. And you see option 1 is value, and so I'm going to hit that. And it'll come up and say, okay, well, X equals what? Well, I want it to be 18 because that's going to represent 2008, 18 years after 1990. And I'm going to hit enter. And at that point, Y should equal, now remember, this was in millions. Our data was in millions. So Y equals 5985.67. And if my data was in millions, that means that the number of internet users we're predicting based on that data from that model is going to be 5,985,666,300. Okay, so about almost 6 billion users, 5.9 billion users, 18 years after 1990. You might want to get on the internet and see how many internet users there are right now. 5.9 billion is getting fairly close to the vast majority of the population, which is what you would expect given what we know. All right, there we go. We did a scatter plot and we performed a exponential regression. I think next time we're going to look at a logarithmic, the inverse of exponentials.